Okay, thank you. Yeah, I'm Adrian, and you may know me from former conferences or where I spoke about the build service, always presenting what it is and what it does. And I guess I thought at least that it becomes boring over time. So I wanted to speak about what else it can do and why you could consider to run your own instance. Assuming that you all know what OBS is. Who knows what OBS is? Okay, who has packaged something already? Okay, not too many. Good thing is, when you want to learn how to package with OBS, then you can visit Henne's talk tomorrow, or his workshop. So he's guiding you through all steps, how to make a package and get it in the build service for SUSE and non-SUSE distributions, I hope. I want to dig into a bit more complex stuff and with some examples what people out there are doing with the build service. Yeah, so many wonder why should they run their own build service at all yourself. I mean, there is build.opensuse.org, everybody can go there, can upload sources, the build service will build it and everybody can download it. So what else would you need? It's well, depending how you see it, but 18 terabytes data, which is constantly rebuilding and hosted and backupped. It's under this regard, 18 terabytes are quite a lot. We have, depending on the times and so on, between 300 and 400 worker instances running. So 300 and 400 virtual machines are building some package, compiling stuff. And because the openSUSE project is such a demanding project, we rarely running the official stable version of the build service. We usually, or most of the time, we have the Git master branch deployed, basically, which is also available as packages. So we eat our own dog food. People like Kulo are working. Kulo is the release manager of openSUSE, so he needs something, and the good thing is that he's not only complaining, but he's also pushing stuff to us, helping us working on the build service. So there is an instance everybody can go and everybody can use, and even better, I mean, there's an absolute perfect admin team. It was never ever down. Everything can be put there, and it had never load problems. So you have not used it, right? Okay, so you know it's a lie. Of course, these are lies. Because we run the latest features, sometimes there are breakages. I mean, we had not really, I can't remember a point of time where we had a loss of sources, and all the binaries are rebuildable, but sometimes it's not reachable. Most of the time it works. Our perfect admin team, well, it's hosted in a location where we don't have a 24/7 support. So if it breaks down on weekend, and and many open source projects working heavily on the weekends, they may need to, in worst case, they need to wait until Monday. Usually someone is driving in and fixing it, but there's no promise for that. And everything can be hosted there. Well, everybody can upload everything, sure, that's true, but the openSUSE project is an open source project in first place, so the openSUSE project has policies, and by default, we only want to have software hosted there which follows the open source rules. So only OSI approved licenses are there. We make some exceptions, for instance for Flash Player and some other binary only stuff which are quite popular, but these has to follow special rules. So if you are just building your own private closed source application, you would need to ask for permission, and if it's not important for the openSUSE project, it's not very likely that they will approve it. Yeah, and the load peaks I mean, there's a monitor page, and you can clearly say when Europe became awake and when the Americans stand up in addition to that. So there's it just has to build suddenly plenty of packages. At some point of time, of course, also it's scriptable. It has an API, so everybody can easily script it and push new stuff. So there are peaks, and the poor build service then need to handle them. Even worse are scenarios. Kulo, our openSUSE release manager, is doing or is creating lots of peaks because he often sets up temporary projects to test something. For instance, a new compiler. What does it break? Before he's checking into factory and making every developer developing for openSUSE impossible. He wants to try out it first. He creates a separate project, and suddenly, in parallel, 12,000 packages needs to be built. So it's just load. Some of these packages are large, but for the main server, actually, the bigger problem are the plenty small packages. We had all this slow hardware in the beginning, so we tuned our workers very much, and nowadays we have added faster workers, and the problem is, in 5 minutes it builds several thousand packages, and the main server has to get the results back, and the 1 gigabyte network interface is already saturating, and the file system is saturating just by reading the results of the build results. And then it needs to reschedule the new builds. So luckily, we will improve that. Soon we will set a second binary backend. So when you noticed that the scheduling state, for instance, is not changing for a longer time, often caused by Kulo, by his temporary projects, that's the reason why we set a second binary interface behind. So Kulo has his playground, and the rest of the world can still work, despite of Kulo. He's not the only guilty guy, but and he has a valid reason. It's not a DOS attack. It's just plenty of work. So this will come in the next few weeks. Still, you might want to say, it still not makes sense for me to build to set up my own build service instance, because maybe it's faster then, but I want to collaborate with others. So I want to use the open build service, and people go there because they find communities, because they can show their work other people, and they get contributions back. So again, you are right, at least the private instance is then not an option for you. But still, also as an openSUSE developer, it can make sense to set up your own instance. For instance, well, of course, there are obvious reasons. There are ISVs out there which builds products, and they don't want to get the source out of their house. So we have mechanics so to hide projects that you can't access them, but we don't want it in the openSUSE project, obviously. So that would be a valid reason to install an own build service instance. And then there are different kinds of people. I know some who really don't want that their build service is talking at all with anything on the internet, no matter whom. So they really have to re-import all the base distribution and reset up it. So it's quite some effort. Plenty of others just setting up their build service at their house and can connect to our instance. So build service has a feature where you configure in the web interface with a mouse click to reuse resources from another build service instance. And this is a default. You can just set up the instance at your place, build, and whatever is needed, it downloads from our instance, for instance. Any questions so far? It's okay to interrupt me. Yeah, that is fast issue. When you stand up in Europe at 6 o'clock in the morning, it's wonderful fast. And when you work then for 6 hours, it's not so fast anymore. So people set up their own instance, and then there are, I know it from some ISVs, from some companies who test their software with it. One extreme I know, one company really rebuilds their, I believe, about 300 packages they have in their product, and they rebuild really the entire product for each Git commit. So they have some stuff around build service which creates a new project and rebuilds their entire source for each Git commit. And they have quite, I believe, 200 or 300 developers. So they have quite a number of Git commits. And yeah, each time the entire thing must be rebuilt. I don't know exactly how long it takes them, but it creates lots of build load. So that's an example. The build service is organized in projects. So you have a project, then you put plenty of sources inside, and you say, I want to build it for SUSE, Red Hat, Debian, different flavors. And yeah, you can automate this. You have a command line client which you can use in shell scripts, or you use directly the API. Who wanted to ask for the full Git integration? Usually someone wants to ask. No one? Usually people are asking when we will use Git directly in the build service. And since 3 years, the answer is, yeah, it's just work. It's fine to do it, it's just work. For 2 years ago, we said, well, we thought about it and written down what needs to be done. Everybody can start it. Until today, no one has started. So everybody wants something, but no one started yet. So I can't tell you when we will have full Git integration. If someone wants to work on this, we are happy, really happy to help. Provide also some code. So far no one showed up. I guess it will happen sometime, but yeah. So back to this example, what this extreme company does, it sets up then projects on top of it, and the nice thing of the build service is that you can reuse resources. So you can say, this project takes all these packages, but I replace this one. For instance, a compiler. And then you configure your repository. It's a bit cryptical down there with link build local dep. That means it builds this package, and then it checks when this package would have been submitted there, what other packages are affected, and it rebuilds only them. So ideally, for instance, you put Qt library inside, it will recompile all Qt libraries and the KDE stuff and nothing else. And yeah, and sometimes you have surprises there, because suddenly it starts to recompile the kernel, and you check, no, the kernel does not link against Qt. But then you can find out later on, okay, but this other package is building a Qt plugin, and this provides a program which generates documentation, and this one is used by the kernel. So these are the kinds of stuff which you don't notice in first hand, which you really need to try out, because changes there don't happen directly. They happen indirectly. Also, kinds of stuff when you know, in RPM there's these scripts and tools which automatically find out about provides and requires of packages. So when you have a Perl package, it automatically adds, provides and requires settings to the package. And when you tune this, you have absolutely no idea what will happen. because it happens so indirectly, so you need to try it out. And you don't want to test it in factory because one easy miss or one overlook and the entire factory is not usable for all other developers. So that's the examples where these kinds of setups are used. And yeah, and the build service itself, the openSUSE instance, you can do all this there, but if you want to be fast and you have enough build power at your place, it's maybe better to set up your own instance and use your local resources, and you don't need to wait for all other builds. Yeah, this is actually the example I was speaking about with Perl. So there's this devil languages Perl package. I believe it's also some Hack Week project where many, but by far not every, packages from cpan got imported automatically. So it's relatively large, the 2,377 source packages. There is another project where really every cpan package is inside, automatically scripted, and this is by far even more packages, but many of them are not building because they are just broken. These are already the hand-selected packages which we consider to be more useful, and they are collected in this Devil Languages Perl project. And since it builds for many distributions, you see from these 2,000 source packages, when we want to rebuild everything, we start about 95,000 build tasks. So a deep change there, for instance, a new Perl interpreter or some base package which changed, it launches so many build tasks. And yeah, for me as a build service administrator, the Perl package is much worse than, let's say, KDE or LibreOffice, because KDE and LibreOffice packages build long. So there are only a few packages and they build long, and well, that's understandable time. This project builds fast actually. On the fastest systems we have, I think we could tune it up to 20 seconds that the build result comes. But then the main server needs to recalculate and reorder it and publish it. And yeah, so tools like Create Repo, which are creating the metadata. So it's a standard tool for creating the metadata that the zipper and yum and so on understands it. They are so slow and so inefficient that the publishing can take hours. Yeah. So, okay, I was too fast with my mouse. So, to test this, again, you would make a project link. You link a project, and the nice thing is that it works not only inside a build service instance, it works also via remote instances. So you have your own local instance. Say, I want to have all sources from this other project without the need to copy it manually. So it's just one line in XML to define this. Then you add your package there. And say, yeah, rebuild it with this special parameter link build gleich local dep. So if you are lucky and you edit a package which influences no other packages, you just get one build result. Everything is fast and easy and fine. If you are unlucky and everything needs to be rebuilt, you will notice as well. Yeah, then there's another example, what could be done with this mechanics. I don't know how it is in Greece. In Germany there's quite a lot of talk about the prism and yeah, all the backdoors which are in what kind of software, and no one knows. The good thing is openSUSE is open source, and the even better thing in openSUSE is that unlike some other distributions, which are also open source itself, but they don't give their tool chain easily away. So for instance, Canonical has Launchpad also open sourced, but I have never heard of anybody who managed to install it. I'm not aware of any running Launchpad installation outside of Canonical. If someone knows it, please tell me, but I'm not aware that anyone ever managed that. With openSUSE, we also open sourced the development stack, namely the build service, in a way that really everybody can running it. So everybody can run the build service, and many do, and you can rebuild the openSUSE distribution, our sources, and then one could compare, or the need would be there to compare all the binary packages. Because of course, when you submit sources to openSUSE, you need to trust people like me that we don't fiddle around with our servers and inject a complete different binary. I mean, you upload nice sources, cool openSSL source. There is no, in the source you will not find any secret service hack. But I could of course just deliver a different package back. Who knows? But the nice thing with the openSUSE project is, or with the openSUSE setup is, someone outside could prove it. Someone outside could really rebuild the sources and compare the binaries. That is of course not easy, but it's not that hard as it sounds, because we have also this build compare script, which is used in first place to speed up the builds. So we have already code which compares two RPMs and decides if there was really a change or not. We use it in first place to reduce the amount of builds or reduce the packages which we needed to rebuild, because we can't say automatically that there is no influence, but we don't want to publish it so that everybody needs to download and install it. And this build compare is there, and this does this work already. So if someone more trusted person than me would set it up in the same way, the rebuild would be already automated, and one could also reduce at least the amount of packages which needs to be reviewed. I mean, I would really looking forward for that if someone tries it, because it would I mean, in best case, some official organization would do it, and we would get some kinds of certification of being not backdoored. But yeah, the point is that only with openSUSE, I think it's even possible at all. Maybe also with Debian. The point is why I think it's easier with openSUSE is with Debian you need to find the old binaries. They don't have a clean rebuild. They rebuild only the package which they think they need to rebuild, but that means that it's not easy automatable. You need to point these binaries from that point of time at when they build another one to have a similar binary to be able to compare it, and that's not the case with openSUSE. Yeah, just for the example, same setup would be syncable with openSUSE. You make a project link, say not link build local dependencies, but link build all, because you have no change, you just want to rebuild it identically. It's basically 2 lines XML in the project configuration to do it. It's really easy to create plenty of build load with a build service. Yeah. Sounds complicated. Yeah, the setup is easy of the projects, as I said. The build service setup of the main server, well, if you're really running a large build service with plenty of users, yes, it will become complicated because you need to consider some load balancing, backups, and so on. But most people nowadays start with the appliance, and the appliance has everything. So it's just downloading the image, starting it, and if you have a DHCP server in your network, it gets a DNS name, then it can configure the Apache and all the stuff automatically, and it just runs. So it's really a one button click installation then. Most people try or many people try to install it from Git. There is not that easy because you need to get the right Ruby gem versions, and that's harder. It's doable, but it's harder. The appliance is also good. I mean, many people think with appliance is always, well, that is kind of a live CD. It's okay for testing, but you can't use it in productive setups. And luckily this changes with all the cloud infrastructure. And what we have done is created some logic that the build service appliance looks for a volume group, an LVM volume group, and if it exists, then it uses this as a data volume. The advantage here is you can throw away your entire image and install the new one, and on the next boot it will just migrate the data to the next, to be prepared for the next build service version. You could also do the zipper dub updates. It's a bit more handwork, but it's also working, of course. But I see it as kind of a prototype for something like when you have real life data in the cloud. Because today many clouds are just, well, you install it once and then you need to live with this image all the time, but you can't restart. With this mechanism, you can really throw away the entire root image, just use a new one, which is built cleanly from scratch using the build service, because the build service itself builds the build service appliance. And yeah, you get the new version, and hopefully everything is correct updated. Any questions? So this is a kitten slide. If you don't have questions, I will tell you what we do next. But it's okay to have questions. Okay. Didn't you expect something else? Some other talk? Always a bit confused if there are no questions. Okay, what we will do this year, as I said, we get the second scheduler backend, which hopefully makes the build service more responsive, especially the scheduling times. Michael Schröter is already working on, the wording there is more transparent binary handling. That are all the flags with publishing and use for build and so on. If you have tried them, that goes back to some design decisions we made in the beginning on how we store the binaries and how we update them. And yeah, there are some problems, and he basically is currently implementing a new method how to store these binaries to be more flexible and more transparent when a package will be used and when not. Then we have already some release management features, so that's good for people who want to build packages first in one project or in one repository, test it there, and if it's fine, if it's good, then it's possible now to release sources and binaries with a command to another project and repository without rebuilding it. So it's actually a side effect from the maintenance features we did. Yeah, and there's an API call now for executing this. The multi-spec file support means if you have a source package, a source, where multiple spec files are inside, because you compile this tarball once with one compiler option and another time with a different one, so you have different flavors based on the same tarball. Currently, this is also possible, but you need to make package links that all builds are running, and we will have a flag that you automatically can say just build everything always. And then all these linked packages go away, which can cause some problems. There's also a better Kiwi image build integration. It's half implemented currently. What's possible now is that you can say in the Kiwi file, or other way around. Currently you have the problem that you define for Kiwi images repositories you want to use not only in the project but also in the Kiwi file. And that is fine because you can say, okay, I want to build this image using openSUSE 12.3, but my build result should be 12.2, so it's good. But the problem is when you have also such a staging project where you test your new packages, your development packages, you want to have also a test appliance, and when you then make changes to the appliance and want to submit this Kiwi file from project A to project B, you would need to modify each time the repository list. Because in one case you want to include the development repository and in the others not. And with this support, which does exist in the Git tree already, is you can say just use the repositories as they are defined in the project. So then you have always the same host and target project system, but it just follows then the definition in the project, and you can just submit your Kiwi files or copy your Kiwi files around in the build service without taking care to modify it. And the last thing is most likely not so interesting for openSUSE. Product and package tracking means that the build service will get a database that it really knows when a binary package got added to which product and when it got shipped to which customer. This is something which we need in first place for our internal instance. Of course, we build it, implement it in the build service, so it will be open sourced. But yeah, I think no one else beside us will use it. But I get surprised sometimes. Okay, I have no slides about jobs at SUSE. I hope you are not surprised, but not disappointed. But yeah, we still just didn't edit it. So, but there are still jobs open, of course. Any other questions? Any problems which stop you from using the build service? You're just hungry, or I don't speak clearly enough. No questions. Okay, then we have the world problem solved. Thank you.